Now, is all fat the same? Well, we have brown fat, which is metabolically active, and white fat, which is storage fat. There are now very good studies showing that your baseline energy rate, if you're in ketosis, is higher than if you're not. So why might that be? Well, these brown fat cells preferably burn fatty acids, which generates heat. So there was a lovely study done where they put people on a low-fat and high-fat diet, gave them the same amount of food, and then measured their weight at the end and measured their energy requirements and outputs during the study. And the effect of being on a ketogenic diet for 4 weeks was basically that the people on the ketogenic diet had done the equivalent of an extra hour of exercise a day compared to the people on the low-fat diet. So your basal metabolic rate ramps up, and certainly when I went on this sort of diet, all of a sudden I just never got cold anymore. Certainly my body temperature is now a lot better than what it used to be. I used to feel the cold reasonably well. And if you look at babies have lots of brown fat. When's the last time you saw a baby shiver? They don't shiver. As adults, we get rid of most of our brown fat, and we need to shiver by using our muscles to generate heat. And that's one of the effects of burning fat. So the brown fat's mainly in the thorax of adults. It can increase or be trained, and this will only happen if insulin levels are low. This has been beautifully studied in rats, and there are some human studies underway which I'm sure will show the same thing. So just looking at the effect of insulin on our ability to burn fat, we can see that when insulin is low again, we burn fat. As insulin increases, we stop burning fat. Even small amounts of insulin impact on our fat burning ability and will take us out of ketosis very, very quickly. And I know I've come back to this 2 or 3 times, but that's a very important thing to understand. All right, so why is it that we need such a radical diet compared to what the government's telling us is good? Well, if we look back over the last few hundred years at what people used to eat, sugar used to be very expensive. It used to be only a treat, something once a week, once a month, and the amount of sugar that people ate back in the 1700s was about 1.4 kilograms. In the 2000s, up to 24, and in fact in a lot of developing countries now, 60 kilograms a year of sugar is being consumed by most people. This includes high-intensity sweeteners and things like high fructose corn syrup. So is it really surprising that the rate of obesity has followed the sugar consumption? Now, a lot of people blame high fructose corn syrup for this. They say that it's being put in everything and that's why people are getting fat. But high fructose corn syrup is 55% fructose. Anybody remember how much table sugar is? 50%. All right? Almost no difference between table sugar and high fructose corn syrup in the amount of fructose in it. Now, initially, high fructose corn syrup was much cheaper than what sugar was, and so that's how it got into all of the foods that were being produced, initially in America and then sort of around the world. And even now, there's this thought process of let's get rid of high fructose corn syrup and replace it with sugar. But you can see it's going to make a 5% difference, almost no difference at all. In this way, the sugar and the high fructose corn syrup have both had a major contribution to the obesity epidemic that we have. Now, the sugar has made it into virtually everything that we eat, and at the clinic, that's one of the things we talk about. So if we are going to eat less carbohydrates, what are we going to eat? Well, it comes back to our original goal. We want to have less of an insulin spike. So what do we eat if we want less of an insulin spike? Well, we can eat protein, but protein gives us half an insulin spike, so that's not very good. What do we want to eat? We want to eat more fat. Despite what most people say, the average person does not need more than 60 grams a day of protein. All right? So if you're looking at 0.7 to 1 gram per kilogram per day for the majority of people. We can talk about bodybuilders, we can talk about weightlifters. There's a lot of differential information out there. My personal belief is probably most of them don't need more than 1.5 grams per kilo per day anyway, and most of them are at 3 or 4, which is just crazy, but that's not really a topic for this talk. So I'm not going to go into too much detail about fat because there's several, I saw on the program, there's several other topics covering fat. And the scientific evidence we have today is that saturated fats are not dangerous. It's as simple as that. On the back page, I've listed a whole 3 things of references of articles and books that are worth reading. And if you want to actually read the scientific stuff yourself, that's where it is. There's an article that actually came out 2 days ago in the BJSM, which is talking about that as well. Trans fats are not shown on the slide because they are dangerous when we eat them. We all have trans fats in our bodies and we need them, but we shouldn't ingest trans fats. But things like coconut oil, extra virgin olive oil, macadamia nut oil, those sorts of things are very healthy and very good monounsaturated fats to consume. So unfortunately, when saturated fat was being demonized over the last few years, the vegetable industry got together and started to massively process their seed oils, which are basically omega-6 containing. Now, we need to be careful that people don't interpret high fat as high any fat. They only allowed certain fats on this diet because all fats are not equal. Eating lots of fat and continuing to eat carbohydrates is very dangerous. If you're going to go high fat, you must go low carb. Don't think that I'm telling you here that it's okay to eat lots of fats if you're continuing to eat your carbohydrates, because that's not what I'm telling you. What will that lead to? That'll lead to obesity and death. So we need to take some time to understand cholesterol. Cholesterol it's basically a specific molecule. It's a particular collection of atoms in order, and it's found in every single human cell. We make nearly 3 times more of it in our bodies than what we eat, and without cholesterol, we die. Since cholesterol is just a molecule, it can't be good. There's no good cholesterol or bad cholesterol. It's just itself. There are many types of lipoproteins, and most people call cholesterol lipoproteins and vice versa, not understanding that they're not the same thing. So, inside a lipoprotein, you will find cholesterol, and you will find triglycerides. And you will notice that there are much more triglycerides than what there are cholesterol. You need to think of the lipoprotein as a submarine floating around in your blood. Now, blood is basically water. This is basically fat. Fat and water don't mix. You need to get your fats from one place to another in the body. How do you do that? You put it into this submarine, which then takes it to the next location and drops off the triglyceride and some cholesterol where it's needed. So without these lipoproteins, you die. So good and bad cholesterol, it's not good and bad cholesterol. Cholesterol is simple. What people actually mean is good and bad lipoproteins. Now, these are the lipoproteins, and they're different sizes, and they have different functions. The one that we're most concerned about is LDL, as we mentioned earlier. So there's also HDL, VLDL, and LDL. And LDL is not as simple as it's all LDL. There are 7 subtypes of LDL of different sizes. They're the major cholesterol and triglyceride carrier in the body. And it's not the cholesterol that's important, it's the triglyceride that's important. Unfortunately, this blood test, looking at your LDL, is one that very few doctors do. Most of them just get an interpreted LDL. So they work out what your triglycerides are, what your HDL is, and then there's a calculation of what your LDL is. What we do is actually measure, using a blood test, what your LDLs actually are, one of the 7 subtypes. Now, these 2 are great. So if you've got a high LDL and it's these 2, you're going to be good. But if you've got a high LDL and it's down here, that's not so good. Now, you can do indirect measures, and there are people that talk about doing triglyceride to HDL ratios, and they are accurate, but why would you do that and work out a ratio rather than actually measure what they are? So these are, again, patients from our clinic. There's type 1 and 2 in green, not very good. 3, 4, and 5, lots of it there. HDL low, which is bad. VLDL high, which is bad. So this person has pattern B, or bad LDL. Now let's look at someone who's got good LDL. Very high 1 and 2, no 3, 4, or 5, high HDL, low VLDL. Now if your doctor saw this, and said, oh my God, your LDL's high, they'll put you on a statin. Is that what you need when you've got good LDL? No. And that's part of the problem with the current set of blood tests that are being done and interpreted the wrong way. So this is another patient with a very high pattern 4 and 5 over here. HDL, skyrocketing VLDL. So what do we want in this patient? We want their type 1 and 2 to go up, their 3, 4 and 5 to go down, and their HDL to go down. What does a low-fat, high-carb diet do for you? That's what it does for you. So this is another way we can track your cardiac risk, is by checking these over time and watching what happens to you. So again, you have to be a little bit careful just recommending this for anybody and everybody and saying, okay, look, I'm going to do this with all my clients right now. There are things that you do have to be a little bit careful of. There's also a test called the calcium score, but I can't go into that today. All right, so again, we're going to just stop for a second because an hour and a half is a long time to talk, so I'm just going to take a sip of water. Any other questions? Yes?
So what is the name of that?
There's only one lab that does it, and it's Douglas Hanley Moore, and it's called lipid subfractions. Yeah.
But if you ask for that, they'll do it wrong.
Yeah. But you see, the other thing about it is that there's no point having the test done unless you know how to interpret it. Right? So there's nuances to it with the number of peaks that there are, as well as the absolute levels. Okay? I'll get Paul to talk about that when he comes up. All right? Because that's also an excellent question. So Douglas Hanley Moyer is the only lab in Sydney, in fact, I think in Australia, that does it.
Sent it off to Macquarie Uni, the Australasian Research Laboratories. So most of the blood companies will be able to forward it to Macquarie Uni. But if you just ask for LDL subfractions, they'll usually not understand it. You have to be very specific. And it's not bulk billable, so it's a $70 out-of-pocket fee.
Yeah, so I don't know if you didn't hear that. That Medicare doesn't cover that test. All right, it's a very specific test. It costs about $70. Yes?
I don't know if too many cardiologists would agree with you on your position on saturated fat and the whole heart disease industry is about reducing the saturated fat.
So we actually have a cardiologist that works with us, and he is totally on board with it. And as I said, what you should do, there's also an English cardiologist named Asim Malhotra, and in the BJSM 2 or 3 days ago, they just published an article basically showing exactly that saturated fats have no connection to cardiac risk for the huge majority of people.
What's your approach? The subfractions, does that increase the predictability of the cholesterol test when currently 50% of people that have a heart attack got normal cholesterol and the first presentation is they're dead? Does that subfraction actually increase that, or are we still stuck at that 50% best practice medicine right now?
So the first thing to understand, it's not cholesterol we're testing, okay? It's lipoproteins, and so you know the nomenclature is a little bit important here. And yes, we know that by changing you from pattern B to pattern A, there's a difference in your cardiac risk. And if there's anybody that we're worried about, there's another test called a calcium score, which is a CT scan of the heart arteries, which is probably even more predictive than that.
I'm going into inflammation. Do you use CRP, high sensitive CRP?
You'll hear about that in about 3 slides. I'm sorry? Okay, so the question is, can the readings be affected by stress? So stress can affect you in many ways, and one of the major ways is by cortisol release. And so if you release cortisol, that can actually, if you're stressed enough, that can take you out of ketosis. If you're not sleeping well enough, there's a lot of factors that can do that. And by doing that, your triglycerides might go up, and then that will affect this level. So yes, but stress is more what you feel than anything else. There are good stresses and bad stresses. So it's hard to be absolute with that answer. But generally speaking, stress in our lives is not good for us. I guess we should probably all be in the yoga or meditation section. Yeah.
The paleo diet, which is very high in protein, good fats,
Yes.
not much sugar, so does that fit into
So the paleo diet uses lots of complex carbohydrates. They say that sweet potato, etc., are fine. Okay, what's a complex carbohydrate? Sugar, 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 sugar. What happens when it gets into our blood? Glucose. What does glucose do? Insulin response. So it's very, very different. Paleo is very different to this. Now, is paleo better than the standard Australian diet? Undoubtedly. Undoubtedly. All right? Because they're not eating all the processed rubbish, which has all the sugars and polyunsaturated fats added to it. But I don't think it's as good as what this is.
So you're sort of talking about big extreme, like I call it extreme paleo diet.
Well, what I say to you is this is how we should be eating. This is a normal diet, and the rubbish that everybody's eating right now is where the extreme diet is.